let's take those skills that we've learned before and apply them to a more difficult problem. So I'd like to teach you how to solve an actual college savings equation. All the pieces, all the bells, all the whistles. Just like if you were my client sitting across from me right now, I could go ahead and teach you and go through the numbers and say, well, this is how much you need to save for college. But to get there, we need to understand inflation. So we'll start with inflation, and then we'll dive into a deeper college saving model. Let's give it the best. So here we go. I have a vivid memory when I was a kid. I remember finally jumping off the high dive, and I was 8, right? And so I mustered the courage and I jumped off the high dive. And as a congratulations, my dad gave me a quarter, and we were at the public pool in Austin, Texas, and I got this quarter, and I went to the Coke machine, I put in a quarter, and I got a Dr. Pepper. I remember it was cold, it was wonderful, it was a surprise, it was so much fun. And I remember I paid a quarter for that Dr. Pepper. And now here, 40 years later, I have an 8-year-old, and when we go to the pool, and if she ever jumps off a high dive, it's about $1.50 for that same Dr. Pepper. And so we can use that concept to understand and solve an inflation rate. What is the inflation rate around that soda? So we can go to our time value of money and we can plug in some variables, right? Present value is what I paid way long ago for that old Dr. Pepper. So I put a quarter in the machine, that's a negative 0.25. Today we would have to pay $1.50, that's $1.50, 1.5 in future value, 0 payment, 40 years, hate saying it, but we can go ahead and solve interest rates. Let's hop over to Excel and give it a shot. So we go to Excel, we go to our saving tool we've created, and remember, everything light blue is a variable that we'll type in. And so present value here is a quarter, so we're going to do negative 0.25. There's no payments in this example, so we'll leave it at 0. 40 years, so 40 periods, 1.5 is going to be the time that's passed, and then we wind up with a 4.58, and that's the inflation rate on that Dr. Pepper, right? Every year it inflated about 4.58% in price, and over 40 years it went from a quarter to $1.50. That's a little bit about how inflation works. Now we can use time value of money to solve inflation. And that's the first step of a college equation. So let's dig a little deeper. The first question I want to ask you is how much college costs, and we're going to flip that inflation conversation a little bit. Instead of solving for inflation, I'm going to give you inflation. So let's assume that 1 year of tuition and fees at U of I is $18,000, and in 2024, that's about what it is. Assume another $1,500 a month for housing and utilities, so your total annual cost is somewhere, give or take, $36,000. Now, like that Dr. Pepper, let's say that these costs inflate at 4% annually. How much will 1 year at Illinois cost 18 years from today, assuming we bring everything forward 18 years? Well, we can use our time value money calculations and go ahead and solve this. We know that 18 is the number of years, 4 is that inflation rate, 36,000 negative is what I would pay for a year of tuition and fees and housing today. Leave payments at 0 for now, and find the future value. Okay, we can hop over to Excel, go to our future value calculator, and plug this in. We have 4 is going to be the annual inflation rate. 36,000 negative is what we pay for room and board and tuition and fees. And then we have 18 years go by, and you wind up with $72,929. So almost $73,000 is what it's going to cost for 1 year here, 18 years from today. Of course, that will change based on the actual inflation rate. 4 is probably a little conservative. In other words, it's probably a little higher than it will be, but that's what we're looking at. So let's go back to our problem on college. So we have the first variable we need. What will college cost in 18 years? Somewhere around $72,929. Now we have a bit of a conundrum, because once we start college, college will still inflate, right? It's not like the day I start, it's locked in, and that's the price for 4 years. At the same time, if I start college with some savings or investments, they'll continue to grow, won't they? And so we're kind of stuck on this question of what rate do I use to inflate my savings once I start college? Because we really have 2 rates going at the same time. We have an inflation rate and a growth rate. So we can work around that using something called Fisher's equation. Fisher's equation gives us a real rate of return, an inflation-adjusted rate, and that'll solve our conundrum here. But to find Fisher's equation, what we do is we say 1 plus r, which is the real rate, equals 1 plus n, which is a nominal or market rate you earned on your investments, divided by 1 plus I, where I is inflation. It makes a little more sense when you see it working. Let's just spitball this one. Inflation costs are estimated to be 4% annually. You believe you can earn 9% on a mix of stocks and mutual funds. What is your real return? We can plug things in. 1 plus R, 1 plus the real return, equal to 1.09 over 1.04. Take 1.09, divide by 1.04, you wind up with 1.048077. Subtract 1 from both sides of that equation, and we find the real rate of return is 4.807. So in this example, we earned 4.807% over inflation. We would use 4.807 as our number if we were calculating compounding growth, if we were calculating discount rates. That's the number we would use in time value of money. So let's apply that technique to our college savings model. All right, here we go. We know what college will cost in 18 years, so let's start filling in gaps. Your niece will begin college in 18 years. At that time, you estimate 1 year of tuition, $72,929. While in college, you believe that she can earn 7% on stock and bonds, and her college costs will inflate around 3%. How much will your niece need to pay all college costs 18 years from today? What is that lump sum that your niece will need 18 years from today so they can spin off those 4 payments? Assume tuition and payments are due at the beginning of each year. Well, Illinois wants to get paid today, right? So the beginning of each year. Well, we need to do some solving, and let's go ahead and see what pieces of this puzzle we need to plug in. All right, how many total tuition payments are there going to be? 4. We're going to make 4 tuition payments. What is the interest rate using the Fisher's equation? Well, your niece can earn 7% in the market. You think inflation will be 3 once they get here. So you would have 1.07 divided by 1.03. You get 1.0388, subtract 1. You wind up with a 3.88% after inflation rate of return. So while they're in school, their money's going to grow at 3.88% above inflation. So let's plug all that in, shall we? 4 is going to be in, 3.88 is I, negative 72,929 is payment, and there's not going to be anything left in the account when we're done, so we'll zero it out. So the question then becomes, how much do they need when they start here? Boom, $275,775. Well, let's hop over to Excel and figure that out. So we'll go to Excel, we'll go to this present value model, and we'll go ahead and plug everything in. We know the rate is 3.88%. We know that there's going to be an annual rate applied over 4 years. We know we've got 4 years of college to deal with. Each year costs $72,929, make that negative. And we're going to get paid at the beginning of each period. Illinois takes the money out at the beginning. So what do I need? $275,775.43. I took the 43 off for the sake of how we're going to present it. But if your niece has $275,775 the day they start college, they'll be able to make 4 years of payments, boom, 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 and they'll be able to grow that money at 3.88 while inflation happens as well. So it's a pretty cool problem, and we've solved it so far. But we're not done yet. There's one more step. You want to pay for it. You say, Craig, $275, let's do it. And I say, all right, let's figure it out. So while you're saving, let's say you can earn 9% annually, right? You can be a little more aggressive before your niece actually gets to college, right? You can take some ups and downs. So we're going to put you in a lot of stocks. And historically, those stocks earn about 9%. So we're going to save, assume we can earn 9% a year, and I want you to save monthly to hit that goal. So here's the question. How much do you need to save per month at the end of each month to help your niece hit that goal? Okay, it seems daunting, but I bet we can do it together. First thing we need to do, what monthly interest rate are we going to use in this math? So we're going to take 9% a year over 12 months. We'll use 0.75% or 0.0075 as the interest rate. Next thing we're going to do is, how many months do you have to save? Well, 12 months over 18 years, you have 216 months. So you have 216 months, you're going to make a payment. And is there anything already saved to the goal? Well, the answer is no. So you'd have 0 in present value. If you had anything, you'd make it negative. All right, So we have 216 in, 0.0075 I. We have 0 present value and we're solving for payment. What do we need to do? Well, if we do this in Excel, I'm going to show you how in a minute, you actually need to save $514 a month and you'll get to your goal. But let's go ahead into payments and we'll figure this out. So we go into payments and we're going to go ahead and set it up down here, 9% divided by 12 months, and we make sure that that's flowing into the rate. Present value is 0. We don't currently have any money set aside. 216 months, 275, 775 is our goal. We want that amount 18 years from today. And we're going to be saving at the end of each month, so make that 0, 514, 17. Let's bring it all together. All right, so what we have when we bring it all together is this. Look, you plan on your niece attending the University of Illinois. Costs today are $36,000. First step, inflate that $36,000 18 years in the future. Boom, $72,929. Second step, how much do they need to pay those 4 years of college when they get there? They need about $275,000 in order to spin off 4 years of tuition, assuming that that amount is growing at 7 and tuition's growing at 3. All right, so far so ambitious. What I need to save a month to help them get there? We're going to find the payment. We're going to find a ordinary annuity payment monthly. Comes out to $514.17. And so to bring it home, if you save $514.17 a month over your niece's 216-month period between the time they're born and they turn 18, you'll have enough to send them to college for 4 years at U of I. It's a complicated proposition, but if you understand this, you are in fantastic shape when we talk about time value of money.